Welcome viewers, we are studying EM waves. As you know, EM wave consists of both electric field and magnetic field and they carry non-zero energy density. You know what is the meaning of energy density? How do EM waves carry energy? Do they carry momentum? Why don't you feel momentum or pressure of the light radiation, EM waves? You must have felt the warmth of the sunlight. Why don't you feel any momentum exerted by the sunlight? Do the EM waves carry energy and momentum? Today we will discuss all these points, so stay connected with me till last. I will give you tricks also that how to learn the important relations so that time can be saved during competitive examination. When you solve the question, you derive any of the relation. How will you learn? Today I will tell you. You know, EM wave consists of both electric field and magnetic field oscillating perpendicular to each other, also perpendicular to the direction of propagation. That's why EM waves are said to be transverse. Now, electric field and magnetic field, they are simultaneously producing their sustained vibrations. They are varying with time and space, and EM waves produced by them. Where you have learned this example in the previous videos we have discussed. Do you know where? Can you tell how the EM waves are produced? Okay, they contain electric field and magnetic field, but how are they produced? We have read LC oscillator by accelerating charge. Where is the charge accelerated in LC oscillations? Across the capacitor plates, and the capacitor is connected with the coil. That means EM waves are produced by the electrical. They carry electrical energy and magnetic energy. They are produced by the electric field and magnetic field vectors, as we have seen. So what is the energy carried by the EM waves and equally shared by the electric field and magnetic field? Today we will see what is the meaning of energy density. Look, energy density means energy per unit volume. As mass density is mass upon volume, so energy density is energy upon volume. What we will do? We will consider a certain volume. Then what is the EM waves? Suppose EM wave is propagating, then through that volume how much energy is contained, then energy per unit volume we will calculate, because electric field and magnetic field vectors are self-sustained. EM waves move from infinity to infinity. Then how much energy you are going to study? Per unit volume. So look, if the charged capacitor in LC oscillations has the energy, that is its electrical energy, in half epsilon naught E square per unit volume. How you are getting? You know this relation half CV square. This C in the parallel plate capacitor, it can be written as, if you write C equal to A epsilon naught upon D, and what is V? Potential difference. V is electric field into D. D is the plate gap and A is the plate area of the parallel plate capacitor. Then half CV square and volume I am writing in words because V is potential difference here. Then volume will be area into distance between the plates and area of one plate. How will you get this relation for energy per unit volume? Look here, if I write this energy by capital U, then look here, this capital U upon volume, you will get here this half C means A epsilon naught upon D into V square, then you will write E square D square, and upon volume you will write A into D. Look, this AD will be here, then AD square will be cancelled. And what will you get? This expression, half epsilon naught E square. As you know, EM waves consist of electric field and magnetic field. How in LC oscillations? Magnetic field, where it is produced? Across the coil, because the capacitor connected with ideal inductor discharges through it. Then what will be the magnetic energy in the coil? You know, magnetic energy in the coil is given by half Li square. So in this energy density term, your whole revision of electrostatic capacitor and inductor energy half Li square you should know. You should know these relations. Even here, what is L? Inductance of the coil. Coil is like this. If I is current flowing through the coil of length L, ideal inductor long length, R is the radius of the loop of the coil, N is the number of turns per unit length of the coil. Then you know what happens when current flow through the coil. Magnetic field is set up in the solenoid. What magnetic field? B equal to mu naught and I. Then what is here? I. This I is B upon mu naught N. What is inductance of the coil? Mu naught N square A L. This L is length, this L is coefficient of self-induction. You know these relations in electromagnetic induction, self-induction, mutual induction we have read. So what will be here? This UB as half, in place of L you will write mu naught N square A L, and in I square in place of that you will write B square upon mu naught square N square. So this N square will be cancelled, this mu naught square and 1 mu naught will be remaining. So you will have only half this B square into AL. What is this AL? A is the area of the loop and L is the this length of the coil. Then what will you get here? This magnetic energy per unit volume, this is written by small u. Here electrical energy per unit volume, this is small u, and I am writing E for electrical, B for magnetic. The per unit volume means you divide it by the volume. Volume means this AL. Then what will you get here? This B square upon 2 mu naught. This is the volume. If you bring this AL upon UB upon this AL, you will get this. So this is the magnetic energy per unit volume. In these two expressions, we have seen what will be the total energy per unit volume of EM waves if you add these two. That will be the total energy. Since E and B, as we have seen, they change, they vary with time. B is B naught sine omega, sine kx minus omega t, and E is E naught sine kx minus omega t. You know, bracket quantities phase, both electric and magnetic field oscillate in same phase. Okay, what is B naught, E naught? Their maximum value of electric and magnetic field. Since E and B are variable, they are changing with time, then you have to calculate the average value of electrical energy and this magnetic energy. How will you find the average value? I am calculating here the average electrical energy. in the electrical energy form, you will write UE bar. What is UE here? Half epsilon naught E square. Then you will write here this half epsilon naught E square and this total bar. Look here, you will write here this UE as you can write average equal to half epsilon naught, and this can be written as E naught square sine square kx minus omega t, and its average. Then what will be UE average? Look here, this UE average will be half epsilon naught this E epsilon naught square and sine square kx minus omega t. Learn, I have told in alternating current also, it is given the average value of sine square kx minus omega t, that is half. So you will put here this half. So what is the average electrical energy in the EM wave? Half epsilon 1 by 4, this half into half, 1 by 4 epsilon naught E naught square. Similarly, you can find that what will be the magnetic energy, average magnetic energy in the coil, in the EM of the EM wave. How will you find this UB average? Again you will write here, what was the formula? B square upon 2 mu naught. So you will write here this half mu naught. In place of B you will put this, what is B naught square sine square kx minus omega t. So again you will get its average value. So what will you get here? This average value, look, 1 by 2 mu naught B naught square, and this average value sine square kx minus omega t is B naught square and E naught square, they are out of this average value. Only these E naught square sine square kx minus omega t sine variation is there and its value is half, rest of the things are here. So here also you will get half and you will get 1 by 4 mu naught B naught. Now we have seen average energy due to electric field, it is 1 by 4 epsilon naught E square, and average electrical and magnetic energy due to magnetic field, it is 1 by 4 mu naught B naught square. This is. Since EM waves consist of both electric and magnetic fields, it is said that these two energies are equal. Half is the electrical energy, half is the magnetic energy. Then prove it. This question is asked that how will you prove that EM waves consist energy density which is equal electrical, equal magnetic. So proof, I am proving this as equal to this one. Let us see, UE average is 1 by 4 epsilon naught E naught square. You know, since C equal to E naught by B naught, then what will be E naught? B naught into C. Put here this 1 by 4 epsilon naught B naught C whole square. Again we know C is 1 by root mu naught epsilon naught, that is speed of EM waves depends on the permittivity and permeability of the medium, so of the free space here. Okay, so this is, you can, C square will be 1 by mu naught epsilon naught. Here you put the value, you 1 by 4 epsilon naught B naught square. In place of C square, what will you write? 1 by mu naught epsilon naught. So this mu naught epsilon mu naught will be cancelled. What is left here? This 1 by 4 mu naught B naught square. What is this? This is equal to magnetic energy average. So in this way we can say the total average energy of EM wave. What will you write? This is UE average plus UB average, as it is defined as EM wave consists of electric and magnetic field both, and energy is equally shared. What will you write here? This is 1 by 4 epsilon naught E naught square plus 1 by 4 mu naught B naught square. Also, it is asked that how will you learn what is the total energy? Either you learn in separate electrical and magnetic energy form, or you have proved just now that this energy, electrical one, is same as magnetic. Then what can you write here? This total energy of the EM wave, average energy, you can write this UE average plus UB average as in the electrical form. Since both are same, then total average energy of EM wave, that will be 2 UE. You can write here or not? These two are same. Then what will you write? 2 into what is UE here? This is 1 by 4 epsilon naught E naught square. That is half epsilon naught E naught square. Or you can write in the magnetic form, that is total average energy of EM wave. Then that will be written as 2 UB average. Okay. Then what will be here? This 2 into 1 by 4 mu naught B naught square. Then what will you get here? Same. This is 1 by 2 mu naught B naught square. So how will you learn? What is the trick to learn? Learn that average energy, that is U average of EM wave, either half epsilon naught E naught square or half mu naught, this is B naught square. Or you can say it is equal to twice UE average in case of electrical, or you can say equal to twice of UB average. So in this way, how to learn the electrical part and magnetic part of energy due to electrical field and magnetic field in the EM waves, and both energies sum together in this way or individually. This is the total energy of EM wave only in the electrical energy. If you consider in the question, it is given half epsilon naught E naught square is the energy of EM wave. Then what will you consider? That is the total energy. Or half mu naught B naught square is the energy of EM wave given, then this is the total energy in magnetic form. Separately, this 1/4 epsilon naught E naught square plus 1/4 mu naught B naught square. So in this way, energy density is learned. Why energy density we have taken? Because EM waves, they are produced in space. So energy per unit volume is of importance. That's why we learn it. Now we will see what is intensity. We will see the intensity of EM waves. Definition of intensity is energy per unit area per second normal to the propagation. How much energy? We have to consider an imaginary area. Suppose we consider this cylinder of length L through which the EM waves are passing, and at t equal to 0 to t equal to t, that is for the time t, they are passing through it. With what speed? Speed of EM wave is c. Then what will be the distance covered? This will be c into delta t. What will be the area of cylinder? This is the area of cross section. And what will be the volume? Imaginary cylinder, we have considered this A into L, that is AC into T, this in the time T. If you consider intensity of EM waves, then that energy passing through this imaginary area we have to consider per second. If you see that energy per unit area for the EM waves, we have calculated how much? This is half epsilon naught E naught square, energy density. Then energy density is the energy of EM wave is half epsilon naught E naught square. If you put here, then what can you write here? This intensity is equal to half epsilon naught E naught square upon what is area, you will write here A into T, here T, and this energy density is per unit volume. Then how much energy will pass through the total volume? What is total volume? ACT. So you will multiply energy density into this volume to get energy, that is into ACT. Got it? Again I am telling, this U is the energy passing through this volume. And what is this? Energy per unit volume. Then energy density is energy per unit volume. Then what we have done? This energy density, that is energy per unit volume into this volume. If you write, then this AT and AT will be cancelled. Then in terms of energy per unit volume, what is the intensity of EM waves can be given? This is the expression. Okay, how will you learn? This is the energy per unit volume or energy density of EM waves, and into C. So energy density into C is the intensity of EM waves. Otherwise, for a light is also EM wave, transverse wave. For a point source, suppose a bulb of 60 watt, okay, 60 watt bulb will give 60 joules energy per second in all directions. If you suppose it is placed at the center of a sphere of radius r, then what will be the intensity of this source? Look, U upon AT we have seen, 60 watt means 60 joules per second, and U upon T, watt per second. You know what is the unit of energy? How will you, intensity, how will you decide? This will be watt, joule per second, watt upon meter square. 1 mark question is also asked that how intensity is related with power. Look here, this is intensity, this is power, unit is watt. So you can write intensity as power upon meter square. This is P, I am writing in words, POWER, power upon meter square. Now you consider a particular area. So the light rays will go at this area. In some numericals it is written that flux, then flux means number of lines passing through, falling on an area normal to it. So this is also given that flux means you are talking about intensity, this energy per unit area per second. Now if you consider here this area will be 4 pi r square, then what will be intensity which is passing through this area? You will write here this P upon 4 pi r square. This is power of the bulb is given 60 watts, so you will put 60 watt, that this will be, I will be P upon 4 pi r square. This power is U by T. So you will, in this way you have seen this intensity is inversely proportional to distance square, as you have seen point charge intensity in electrostatics. What was the formula for point charge at a distance r? The electric field intensity at that point, 1 by 4 pi epsilon naught q by r square. Similarly here, intensity of EM waves, how will you write here? This E square proportional to I. Rest of the things are constant. So intensity of EM waves, how will you learn? Energy density into C. On what factors? It depends. Look here, this electric field square. Here intensity for the point source. Here we have seen that for a light point source, this will be distance square inversely proportional. What is unit? Watt per meter square. What is its relation with power? This. Now, how will you tell that you must have experienced the energy of EM waves? You put your hand in sunshine. You feel warmth. Warmth means heat. Heat means energy. So energy is carried by EM waves, light energy. Sunlight also EM waves. So energy is carried by EM waves. What is energy density? We have seen. Energy is equally divided into electrical portion and magnetic. That is, electrical energy of EM waves and magnetic energy of EM waves, both are equally shared. Now, do they carry momentum? Since in the 19th century, it was supposed by the scientists that waves can travel in a medium, and EM waves do not require any medium. They can travel through medium as well as through vacuum. Since now we know that electric field and magnetic field are self-sustained, but earlier it was not known till Maxwell prediction about EM waves that waves can travel in vacuum. What is today? EM waves like light waves and other waves, those properties I told, that EM waves carry momentum. As you know, wave particle duality, dual nature of light. Light waves are supposed to be acting, behaving like the particle as well as like the wave. What are the wave phenomena? Diffraction, reflection, refraction, interference. Young's proved the wave nature of light successfully, and Einstein proved the particle nature of light successfully. In the modern physics you will learn about the particle nature. Light is supposed to be form of energy bundles, energy packets called photons. Also, de Broglie has given the matter waves. As per his concept, if the light is a wave and it can behave like particle, then all the particles, they are moving particles, with them waves are associated. And what is the wavelength? That is, those waves are called matter waves, and the wavelength associated with the matter wave is given by lambda equal to this h by p. H is Planck's constant. What will be P here? This is h by lambda. If the EM wave is traveling like this, okay, in the path of EM wave perpendicular to the propagation, if you consider a plane, some charges are there. If at that plane, then they will be set in motion and by the electric field and magnetic field, sustained motion of electric field and magnetic field. So they will start oscillating, and they will confirms that EM waves carry momentum also, because momentum suppose it is attached with the particle nature. So EM waves, what particle? It has been supposed that in the propagation of EM wave, if a plane is considered at which some charges are present, then they will also oscillate and they will have momentum. That proves that EM waves carries momentum and energy. What is momentum? If you write EM waves, they are propagating here, then you know, if the frequency of EM waves is nu, then what will be the energy? I have shown here by U, then U will be h nu. What is nu? Nu is C by lambda. you put here, then what will you get? U equal to hc by lambda. What is h by lambda here? This is p. Then U equal to p into c. That means this p, what is p? Momentum is u by c. And if a EM wave is reflected back, then what is the momentum? This will be 2u by c, because minus u by c after reflection, and when it was moving towards that surface, then u by c. So change in momentum will be 2u by c. Why don't you feel this momentum? You feel warmth. That means you feel energy. Why don't you feel the momentum? Because this is c in the denominator. Its value is very large, 3 into 10 to the power 8. So this momentum is very, very negligible, so that one cannot feel. Also, EM waves are supposed to be exerting pressure on the surfaces, and that pressure is also very, very less. It has been obtained that the pressure exerted by EM waves is 7 into 10 to the power minus 6 Newton per meter square. This is called radiation pressure. So this question is also asked that do they carries these EM waves, do they carry energy and momentum? What will you say? Yes. How? I have given in detail that energy of EM waves, energy density of EM waves, what is momentum, do they exert pressure, radiation pressure? Yes. Now I hope you must have enjoyed. Thank you.